If oxidation in the reduction which is taking place simultaneously within a single step, then only we can say it is a redox reaction. So redox reaction is a reaction in which both the oxidation and the reductions which is simultaneously which is taking place in a single step. In the mercuric oxide, you are removing the oxygen, so it will form a mercury along with the oxygen. Hence the reduction will be taking place where you are taking out the oxygen from this mercuric oxide. Understood? Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with a new unit called redox reaction. So before going to discuss with this unit, let's see the weightage of this unit. So from this unit, we can expect one 1 mark question and one 3 mark question. So the question number 5 in the part A that comes from this unit and the question number 23 in a part C that carries 3 marks which comes from this unit and the total weightage is 4. Okay. So we can easily get 4 on 4 from this chapter. Okay. So let's see what we are going to discuss in this session. So in this session, we are going to understand what actually are oxidation, what is reduction and how does redox reactions will be taking place and a reducing agent and oxidizing agent. Then coming into the oxidation number or the oxidation state and what are all the rules which we followed to find out the oxidation state or the oxidation number of the given element, let us discuss in this session. So firstly, I'll move towards the oxidation. So during oxidation, the removal of the electron will be taking place in a different way. So the oxidation is a process in which any one of the following changes can be taking place. Here I have listed out the few different changes which is taking place during the oxidation. In terms of oxygen, if I talk, the addition of oxygen is known as oxidation. In terms of hydrogen, if I say, loss of hydrogen or the removal of a hydrogen is known as oxidation. Suppose if I define the oxidation in terms of electron, then it can be said that addition of electronegative element. In terms of electropositive element, if I say, it is a removal of electropositive element. So in terms of the oxidation, in terms of oxygen, in terms of hydrogen or in terms of electron also, we can define the oxidation. Hope you all understood that what is oxidation. In terms of oxygen, if I say addition of oxygen, it is said to be oxidation. If I define the oxidation in terms of hydrogen, then I can define that oxidation is nothing but a removal of hydrogen. Hope you all understood this definition about the oxidation. I have listed out the two examples for the oxidation in terms of oxygen, in terms of hydrogen or in terms of electropositive and electronegative element. First, I will go for the addition of oxygen. This is a metal. We know that this is a magnesium. When it adds the electron, oxidations will be taking place in the magnesium. Is it right? Similarly, you can take the sulfur. When you add the oxygen to the sulfur, it becomes sulfur dioxide and this is a oxidation of sulfur. This is how by adding the oxygen to the element which forms a oxidation. Which forms what? Oxidation. In terms of hydrogen, if I say hydrogen sulfide plus chloride give rise to the hydrogen chloride plus sulfur. Here the sulfur is displaced with the chlorine so that the removal of the hydrogen will be taking place from the H2S and so that S will be get separated. So it is oxidation of H2S. Why? In the H2S, hydrogen is removed, hence this is known as oxidation. So where the removal of hydrogen which is taking place. Then coming into the electropositive elements. Here I have considered the magnesium where the chlorine which is added so that oxidations will be taking place in the magnesium when you add the electronegative element. By adding the electronegative element to the metal, obviously it follows the oxidation. You can take the another example. To the same metal I have added the another electronegative element, that is fluorine. It forms a magnesium fluorine, where the magnesium is undergoing the oxidation by adding the fluorine as an electronegative element. Similarly, you can take the another example of sulfur, where it is added to the magnesium and forms a magnesium sulfur, and again oxidation of the magnesium will be taking place because you are adding electronegative element. And coming into the electropositive element, if you remove the electropositive element, then it has become oxidation. For example, in this complexes, okay, the iron, cyanide, hexacyano-iron, in this, which is allowed to react with the water, you can see that one of the potassium is removed along with the water and forms a potassium hydroxide. Here, the removal of the electropositive potassium from this entire complex which is forming a oxidation because you are removing the electropositive element. So, it will form a KOH. So, finally, we can define that oxidation is nothing but the addition of hydrogen, or oxidation can be defined as a removal of hydrogen or the electropositive element from a substance. This is how we can easily define the oxidation. In terms of hydrogen, it is known as removal of hydrogen. In terms of oxygen, if I say, it is a addition of hydrogen. This is how we can easily define the oxidation. Next, we'll go for the reduction. Reduction is just a reverse of oxidation. The reduction is a process in which any one of the following chemical changes will be taking place. Again, I have listed out in terms of oxygen, in terms of hydrogen, or in terms of electropositive metal or with the electronegative metal. First, I'll go for the oxygen. The removal of oxygen from the metal, it is said to be a reduction, where in the mercuric oxide, you are removing the oxygen, so it will form a mercury along with the oxygen. Hence, the reduction will be taking place, where you are taking out the oxygen from this mercuric oxide. Understood? Because you are removing the oxygen, hence it is a reduction. In terms of hydrogen, if I say, I have taken out the ethene along with the hydrogen. So what it will form? Again, the hydrogen will be removed from this and it will be undergoing the reduction. Why it is added here? Because the addition of hydrogen, it is said to be reduction. That is why to this ethene molecule adding H2, so that it will become CH3CH3, you are adding hydrogen, hence it become a reduction. But here, you are removing the oxygen atom, hence it become a reduction. But in terms of hydrogen, it is a addition of hydrogen. In terms of electronegative element, so here I have taken out the ferrous chloride which is allowed to react with the hydrogen. It will form a ferric chloride along with HCl. The reduction of ferric chloride will be formed. Why this reduction will be taking place? Because from this ferric chloride, the electronegative element will be removed out. Is it right? Hence, this is a removal of electronegative element from the complex. Hence, this is known as reduction. Then coming into the electropositive element. In this, mercury chloride and stannous chloride, which is allowed to react, it will form a mercury chloride and a stannous chloride. So here, the addition of the metal will be taking place. You are adding the chloride here. Is it right? So it will form a reduction of mercury chloride. Why does the reduction of mercury chloride? You are adding the metal here so that the reductions will be taking place. So finally we can say that reduction is nothing but a removal of oxygen and addition of hydrogen. This is how we can easily understand what is the oxidation and what is the reduction. So, always remember, in case of oxidation, in case of reduction, in terms of oxygen if I talk, okay, in case of oxidation, it is a addition of oxygen, but in case of reduction, it is a removal of oxygen. In case of oxidation, if I talk about the hydrogen, it is a removal of hydrogen. In case of reduction, it is nothing but a addition of hydrogen is known as reduction. This is how we can easily remember the oxidation and the reduction in terms of oxygen as well as in terms of hydrogen. Next, we will understand what is actually a redox reaction. So, redox reaction is a reaction in which both the oxidation and the reductions which is simultaneously which is taking place in a single step. Then we say it is a redox reaction. The reaction in which electrons are transferred from one atom to the another atom, where oxidation and the reduction reactions will be taking place, where the loss of electrons will be known as oxidation and the gain of electron which is known as reduction. An easy way to identify the substance being oxidized or the substance is being reduced can be easily remembered with the acronym known as oil rig, where oil rig is nothing but oxidation is a loss of electron, okay, whereas a reduction is a gain of electron. This is how, by using this acronym, we can easily understand what is an oxidation and reduction in terms of electron. In terms of electron, I am talking, so that oxidation can be defined as oxidation is a loss of electron, whereas the reduction is a gain of electron. So, we can easily remember with the oil rig. So, finally, we have understood that we have a table, is it right, for remembering the oxidation and for reduction. Is it right? In terms of oxygen, in terms of hydrogen, in terms of electron. In terms of oxidation can be defined as, it is nothing but a addition, it is removal of hydrogen, then it is removal of hydrogen, then it is addition. Is it right? The same thing which we have discussed in the last. And in terms of electron, if I say, oxidation is nothing but a loss of electron, whereas a reduction is a gain of electron. This is how, in terms of oxygen, in terms of hydrogen, in terms of electron, we can easily remember what is an oxidation and what is an reduction. Remember, if I say it is a redox reaction, it is a reaction in which both the oxidation and the reduction must happen in a single step. Then we say it is a redox reaction. Here I have an example of sodium chloride. So let's see which element is going to lose the electron or which element is going to gain the electron in terms of electron. Okay, in terms of electron transfer, let's see now. So here I have a sodium metal which is allowed to react with the chlorine. Okay, we know that it will form a sodium chloride. We know that the sodium will loses the 2 electron, so it is undergoing the oxidation. It is nothing but a oxidation. Whereas our chlorine, which are accepting these 2 electrons which is given by the sodium, so it is gaining 2 electrons, so it is undergoing reduction. Is it right? So in both of these steps, both the oxidation and the reduction which is taking place, hence we define it as a redox reaction. And we can easily write this reaction as sodium plus chlorine give rise to sodium chloride. Okay, and this sodium which are undergoing the oxidation, whereas the chlorine which are undergoing the reduction. Both oxidation and the reductions which is taking place, then only we can say it is a redox reaction. Then only we can say it is a redox reaction. Hope you all understood with this concept, and always try to remember with the oil rig. Okay. Next, we'll have another example. This is a sodium metal which is allowed to react with the oxygen and forming a sodium oxide. Is it right? Here again the sodium will loses 2 electrons, so it is oxidation. Is it right? And here oxygen is accepting the 2 electron, so that we can say that it is a reduction. Is it right? So both oxidation and the reduction which is taking place, hence it is an example for the redox reaction. Similarly, I have another example where the sodium will loses us 2 electron and become oxidized, whereas our sulfur which accepting the 2 electron, so it get reduced. Reduction will be taking place. Hence, this is the example for redox reaction. Redox reaction. This is how, if oxidation and the reduction which is taking place simultaneously within a single step, then only we can say it is a redox reaction. Sodium, we know that it loses electron. But in the sodium, we know that there is only 1 electron in the outermost shell, so it can loses only 1 electron. This 1 electron will be accepted by the chlorine and forms a Cl minus. Is it right? It will form a Cl minus. So, in order to balance this, because 2 Cl are there, so we will write 2, then again 2, 2 and 2. So, I can write this one is undergoing oxidation. Why it is undergoing oxidation? Because it loses electron. Whereas the reduction, why it is known as reduction? Because it gaining the electron. Is it right? Yes. So, I will cancel these two electron and then I can write 2 Na plus Cl2 give rise to Na plus and Cl minus. This reaction is known as redox reaction. Why it is known as a redox reaction? Because in a single step, both oxidation and the reduction will be taking place. So, it is redox reaction where 2 molecules of the sodium will be loses 2 electron and thus 2 electron will be accepted by the chlorine and forms a 2 Cl minus, where the sodium is undergoing oxidation whereas the chlorine which are undergoing reduction. This is how we can easily understand the formation of sodium chloride, where one is undergoing the oxidation and the one which is undergoing the reduction in terms of electron transfer. So, always remember this example will be done only when the molecules are ionic in nature. When the molecules are ionic in nature, we can go through with the electron transfer. Okay. Next, we will understand what is an reducing agent and what is an oxidizing agent. First, we will discuss what is reducing agent or reductant. As substances that can readily loses the electron to the other substances are known as reducing agent. The substances that can readily lose the electron to the other substances, they are known as reducing agent, whereas the oxidizing agent are also known as oxidant, can be easily defined as the substances that can readily accept the electron from the substance is known as oxidizing agent, and so the reducing agents are the electron donors, whereas the oxidizing agent is a electron acceptor. These sentences you must understand. So, I can take the example of sodium which reacts with the chlorine and forms sodium chloride. Here, we know that reducing agents are the electron donors. Is it right? Reducing agents are the electron donors. We know that here in case of the sodium chloride, which one is a reducing agent? We know that the chlorine is a reducing agent, but in case of the reducing agent and the oxidizing agent, which is known as electron donor. Why it is known as electron donor means it will donate the electron. So here the chlorine is a electron donor, whereas the oxidizing agent are the electron acceptor. So this is sodium is a electron acceptor. This is how, we can easily remember it in terms of reducing agent as well as with the oxidizing agent. So here, which one is known as oxidizing agent? Oxidizing agent means it will donate the electron. Which one is donating the electron? Here the sodium is donating the electron. Is it right? Which one is accepting the electron here? The chlorine is accepting the electron, hence it is a oxidizing agent. This is oxidizing agent, and this one is reducing agent. Why sodium is known as reducing agent? Because it donates the electron to the chlorine atom to form a sodium chloride. Here I have an example of, in case of water molecule, you can easily understand that the hydrogen which combines with the oxygen and forms a water molecule. Is it right? Yes. We know that hydrogen which is undergoing the oxidation by losing the 4 electrons. Whereas the reduction will be happens because the 4 electrons will be accepted by the oxygen atom. Is it right? Yes. Here, which one is a reducing agent and oxidizing agent? We know that hydrogen itself is a reducing agent because it donates the electrons to the oxygen. Whereas this one is a oxidizing agent. Why? Because it accepting the electron. Understood? Similarly, in case of ferrous chloride, which is allowed to react with the aluminium and forms the aluminium oxide and 2Fe2+. Is it right? So, in this case, both oxidations of the 6 electrons will be taking place and the reduction of 4 electrons will be taking place, so that the iron 2+ is a electron accepting, so that it is undergoing the oxidation and the reduction respectively. And next we'll see that what is an oxidation number. Oxidation number or the oxidation state can be defined as oxidation state or the oxidation number of an element in a compound is a real apparent charges on the atom of an element. It is nothing but a real or the apparent charges which is present on the element. I have an example of sodium chloride. We know that if I write the sodium chloride, we know that the sodium which having +1 charge, whereas the chlorine will be having -1 charge. This is the apparent charges of this element. Is it right? And maybe it is a real also. Hence, this is known as oxidation number of sodium is +1, whereas the chlorine is -1. And the oxidation number of hydrogen is always +1, whereas for the oxygen, it is -2. So, this is a common thing that we followed while calculating the oxidation number of the given element. Remember, always the hydrogen will having a +1 oxidation state, whereas oxygen will be having -2 oxidation state. Now, we'll see what are all the rules which we followed to calculate the oxidation number. The first rule says that the oxidation number of an atom in an elemental state is 0, is always 0. For example, in case of Cl2, H2 and O3 and S8, Na, Mg and Al, for all these elements, they are nothing but gases. So that this element, if they are exists in the elemental states, their charges will be 0. The oxidation number of the such elements will be 0. Then the rule 2 says that the oxidation number of an ion is equal to its charges. For example, sodium which having plus charge, which indicates that which having +1 oxidation state. Similarly, the chloride minus ion which shows that it having Cl minus. It shows that it having -1 charge. You can take the example of Al3 plus. For the aluminium, the charge is +3. Similarly, for the magnesium, Mg2 plus we will write. So, this is a charge on the ions. So, it will become a oxidation number. Then the rule 3 states that the oxidation number of hydrogen in all the compound containing hydrogen is +1, except the hydrogen forms a compound of hydrates. If hydrogen is there in all the compound, their oxidation state will be +1, except in the hydrate. So that in the H2O, we all know that it consists of hydrogen. So that oxidation state of hydrogen is +1. Similarly, for the oxygen is -2. But in case of a hydrate called as sodium hydrate, the oxidation state or the oxidation number of hydrogen is -1. That is why the rule 3rd says that the oxidation number of hydrogen in all the components +1 except in hydrate. And then oxidation number of oxygen in all the compound containing oxygen is -2 except in the peroxide. So in the peroxide, which shows -1 oxidation state, but in all other compound which are containing the oxygen, they shows a -2 oxidation state. Example here, in the H2O, oxidation state of oxygen is -2, whereas in H2O2, their oxidation state will be -1. These are the certain rules which we have to remember while calculating the oxidation number of the given element. Next, rule 5 says that algebraic sum of oxidation numbers of all the atoms present in one molecule of an atom, present in one molecule of a compound is 0. And that is, for example, if I calculate the oxidation number of water, okay, I'll consider how many hydrogen atom will be there? 2. So what is the oxidation number of hydrogen? It is 1. So plus, we don't know what is the oxidation number of oxygen. I'll consider as x. So it will be equal to 0. Why? Because the algebraic sum of oxidation number of all the atom present in one molecule is 0. So it is 2 plus x is equal to 0. So x is equal to -2 if I want to calculate the oxidation number of oxygen. This is how we will consider the oxidation number of certain compound. The algebraic sum will be 0. But in case of polyatomic molecules, it will be mainly depends upon the charges which is present in the ion. So both the thing we need to follow while calculating the oxidation number. In case of a compound, their algebraic sum of oxidation numbers of all the atom present in the molecule is 0. But in case of polyatomic molecules, their oxidation numbers will be not equal to 0 because their charges will be also present. We need to consider the charge. Okay. Next, oxidation state of halogen in their compound is -1, but in interhalogen compounds of chlorine, bromine and iodine, more electronegative of the two halogen atom gets the oxidation number -1. For example, in the bromine, the oxidation number of chlorine is -1 while the bromine is +3. When the chlorine, bromine and iodine are combined in a oxygen atom, for example, oxo acid and oxo anions and halogen have a positive oxidation number. This is how, we can easily understand that if it is an halogen, their oxidation number has to be changed. Then rule 8 says that the oxidation number of alkali metals with their compound which always possesses a +1 oxidation state. So the group 1 element in the periodic table, that is hydrogen, lithium, sodium, potassium, rubidium, cesium, all this element, this shows a +1 oxidation state. Whereas even the alkaline earth metal which has been present in the periodic table, this shows the +2 oxidation state. So alkaline earth metal, they shows a +2 oxidation state, for example, magnesium. Now let's see how to calculate the oxidation number of a given element. Okay, here whatever the letter which have made pink color, they are nothing but a element whose oxidation number has to be calculated. Okay, so we know that in a H2SO4, let X be the oxidation number of the sulfur atom. We know that there are 2 hydrogen atom will be there, 2 plus 1. Why it is +1? The oxidation state of hydrogen is +1 plus X plus 4. Why it is 4? There are 4 oxygen atom will be there. 4 into -2. Why it is -2? Because already we have understood that for the hydrogen it is +1, for the oxygen it is -2. Is it right? So it is -2, so it is equal to 0. So 2 plus x minus 8 is equal to 0 and x value will be 6. So the oxidation number of the sulfur is 6. Similarly, in case of potassium dichromate, here for the chromium atom, we need to calculate the oxidation number. So it is 2 into plus 1 plus 2x plus 7 minus 2 is equal to 0. 2 plus 2x minus 14 is equal to 0 and 2x is equal to 12 and x is equal to plus 6. This shows that the oxidation state of the chromium atom is plus 6. In case of Fe2O3, let the oxidation number of iron atom we are calculating. So that 2x, because there are 2 iron atom will be there, 2x plus 3 into minus 2 is equal to 0. 2x is equal to 3 2 is 6 is equal to 0. 2x is equal to 6 and x is equal to plus 3. So oxidation state of the iron is plus 3. In case of manganese dioxide, in case of this manganese oxide, in this case, we need to calculate the oxidation number of manganese atom or the manganese atom. So it is 2x. Why? Because there are 2 Mn will be there. 2x plus 7 minus 2 is equal to 0. So 2x, 7 2s are 14, minus 14 is equal to 0 and 2x is equal to 14 and x is equal to 7. So oxidation state of the manganese will be 7. Now I'll do the sum of the numericals just to understand that how to calculate the oxidation number of the given or the underlined element. Okay. Here again MnO4 minus. So Mn is X be the oxidation number of manganese atom. So X plus there are 4 oxygen atom minus 2 is equal to how much we don't know, it is minus 1, because it is minus means nothing is there means it is 1. So x 4 2s are 8. 8 is equal to minus 1. So it will be 7. So 1 minus 8, it is 7. So this is how we can easily calculate the oxidation number of the underlined given compound. Similarly, I will go with the Cr2O7 2 minus. So I will consider 2 into x plus 7 into 2 minus 2 is equal to minus 2. Is it right? 2 minus it is there. Charge is there. So it is 2x plus 7 2s are 14. 14 is equal to minus 2. 2x minus 14 is equal to minus 2 and 2x is equal to, so it is 12. So x is equal to 6. So it is plus 6. Is it right? So oxidation number of the chromium is plus 6. So again for the hydrogen it is 1. 1 plus x. So there are 4 oxygen atom will be there is equal to minus 1 because only one charge is there. 1 plus x. 4 2s are 8 and it is minus 8 is equal to minus 1. So 1 plus x is equal to 7 and x is equal to 7 minus 1. It will be equal to plus 6. This is how we can easily calculate the oxidation number of the given element. In the next session, we are going to discuss with the stock notation. By this, I like to say that what are all the things which I have covered in this session, it is very important for the examination point of view. Have a look on it. So, we'll meet you in the next session. Till then, take care and be safe. Thank you.